Okay, hello students, welcome to the final lesson of Unit 1. Today we're going to be looking at piecewise linear graphs and step graphs. So we're going to be able to sketch these graphs and use technology like Excel or Desmos where appropriate, and then we want you to interpret them in practical situations. So a step graph consists of one or more horizontal non-overlapping lines that follow a step-like pattern, and so on. Now the closed circles indicate an included point, though you can see that we've got a greater than or less than or equal to sign, whereas the open circles indicate an end point, and so we just got greater than or less than sign here. So if I had a look at, for example, Bundaberg's water rates, there's two steps to it. There's 95 cents per kilolitre for the first 183 kilolitres for every 6 months, and then $1.60 per kilolitre for every kilolitre of consumption thereafter per half year. So what we've got here is a step graph to represent that. You can see that on the bottom graph, on the bottom axis, the x-axis, I've got the kilolitres. So here's our information here, so it's per kilolitre. And you can see that I've included, what have we got? An open circle and a closed circle here. So for the first 183 kilolitres, you're getting charged 95 cents. So if you use 140 kilolitres, for example, you can just read off that line, and you'll notice that it will still be charged at 95 cents per kilolitre. Now the second step is $1.60 per kilolitre after the 183. So if we're looking at, for example, 200 kilolitres, here we are, you're going to be charged 95 cents or $0.95 for the first 183 kilolitres, and then for every kilolitre after that, you're going to be charged $1.60. Now, it's kind of obvious that councils will use this sort of strategy just to stop the old pensioners watering their lawns all year. But if you like the privilege of having a green lawn, of course you're going to pay the extra amount. Now, we can also represent this as a piecewise graph. Now, a piecewise graph just is a line graph with each segment following a different rule. Now, we saw that with PAYG graph a couple of lessons ago, and we'll have another look at that today as well. But to represent the water rates for Bundaberg, let's have a look at our piecewise graph. So a piecewise graph consists of one or more non-overlapping line segments, and each of these segments follow a different rule. So remember, our first step was 95 cents a kilolitre for the first 183 kilolitres of consumption per half year. And then the second step is $1.60 per kilolitre for each kilolitre of consumption thereafter per half year. So for the first 183 kilolitres, you're going to be charged $173.85 for every 6 months. If you're going to use more than that, you just add on that 173, and then we do that minus. And so, for example, we're looking at 220. I got this here, and at 220 take 183 at the higher rate of $1.60. That will bring it to a total of $232. So what you can see when I've drawn this graph, zero amount gets used, zero is charged up to 183, and then I just connect the dots. So I had to do the calculation to connect the dot. The second calculation of 232 for 220 litres, that was just right at the edge of my graph. That's why I use that scale. So if you went up to 250, you'd just put a 250 there, for example, to connect that scale. So I just connect that other dot there, and we've got our turning point, or the point at which each segment becomes important. Now, as I said, we did this for pay-as-you-go tax. So that's your income tax in Australia. So we can have a look at our different rates. So for $18,200, you get no tax at all. But after $18,200 to $37,000, you get charged at 19 cents per dollar over $18,000. So that's a gentle curve represented here. That has a gradient of 0.19. And so it's a bit flatter than, for example, the next one, which has got a gradient of 0.325 or 32.5%. So the second tax bracket, or the third tax bracket, if you're going to include the non-taxable bracket, is $3,572 plus that 32.5% for each dollar over $37,000. Now this makes sense that 19 cents of $37,000 minus that 18,000 tax-free threshold, that should be 18,200, sorry, will give you 3,572. So if we look at the next bracket here, that's going to be represented by this line. And so that's getting a little bit steeper. So we just need to note the turning point, and then we can connect the segments from there. So if we have a look at the next one, it's a little bit steeper again. So we're at 37% or 37 cents for every dollar over $87,000 for this next tax bracket, plus that 19,822. So this segment from here to here is at 37 cents or 0.37, and that's the gradient for that section. The final tax bracket is at 45%, so that's 0.45. So the government lets you keep 55 cents, and it takes 45 cents for every dollar over $180,000 that you earn. And so you can see that this piecewise linear graph has one or more of those non-overlapping line segments, and each of those segments are following a different rule. And you can see that the gradients are changing, in particular here, as we are going along. So we can also draw this as a step graph. Now I've used this in Microsoft Excel, and it's given me these bits extra, and typically I don't want you to draw them in. So we'll have a look at a real one soon, but I'll show you how to do this on Excel in a little while. So if I were to interpret the tax brackets and to put them into a step graph, you can see that for the first $18,200 you're charged no dollars at all. So, but if we have a look here, you're charged from $18,000 to about 37, is it? 37,000. My scale could be a whole lot better on this graph, sorry. So we charge, what is that rate? It's 32.5, and that makes sense because it's exactly halfway between these two. Now if we have a look at the next tax bracket, what do we read across? That should be 0.37 as indicated here. So that's the next step on this step graph. Finally, we've got 45 cents for every dollar over 180,000. So you can see the next step here, and that would be $80,000 here for this step where that becomes important. Finally, there's two sorts of piecewise graphs that I want to make a point with, is that they can be continuous or discontinuous. And you can see on the left hand side all the lines join up, so that means it's continuous. On the right hand side the lines do not join up, so that means it's discontinuous. The next point I'd like to make is that we've got y equaling 3 rules here for a variety of sets of values. So for example, on our continuous line graph on the left hand side, y equals 2 plus x when x is below or equal to 0, and then y equals 2x plus 2 when the value of x falls between 0 and 10, and then y equals 32 take x when x is greater than 10. So we just want to calculate the key points. So you might calculate, for example, the value of y when x is negative 10, and when it hits 0, because that's our turning point here. So we've got a 0, and then you just pick a negative number which fits on the graph, and then you can plot that on the graph. Then we got from 0 to 10. So we're just going to have to think, well, there's our 10, there's our 0. So we're just going to say y equals 2 times 0 plus 2. Well, there's 2. So that's going to be our first value, x equaling 0 and y equaling 2. And then we've got 2 times 10, which is 20, plus 2 is 22. So that's going to be our next value. So 10, 22. And then we can just finish off with the final set. Y equals 32, take x, when x is greater than 10. So we just say, well, 32 take 10. Well, that's 22 when x equals 10. So we've got x equaling 10, y equaling 22. Then just find another point. Well, on this graph, it's going to finish at 15. So 32 take 15 is 17, and that should be here. So x equals 15 on this point, and y would then equal, I think we said 17. If we have a look on our discontinuous line graph, you can see that I've done the same thing. So y equals x when x is less than 0. So from here, that way, x is less than 0. So, for example, when x is negative 4, y is negative 4. They have the same value. From between the values of 0 to 4, y equals 5 plus x. So that's got to be this segment here. So you just construct the segment for the line graphs there. Generally do 2 points for a line, or 3 if you want to be sure that it's linear. And then finally, for the final set of values, y equals 6 take x when x falls between the values of 4 and 9. Okay, in this Excel spreadsheet, I've created a step graph for the PAYG scales, and you can see there's something interesting going on here. I've entered in my taxable income scales twice. I'll just show you why. If I should delete that and delete this one, for example, you can see things starting to miss out. But if I were to enter them just once, I would form lines on an angle, and that would not be a step graph then. So when you're constructing these stepwise graphs, just place in each value twice, so the start and the finish value. So for example, with our taxable income, let's look at our second tax bracket of 18,200. You're going to be charged at 19 cents for every dollar over 18,200. I keep copying and pasting the wrong one through there. So at the start of 18,200, you're not going to be charged a cent. But at the end of 18,200, or as soon as you hit that, you're going to be charged 32.5 cents. So that's what this is indicating here. From 18,200 all the way up to about 37,000, you are being charged this amount here, which is 32.5 cents. Now, once we get to 37,000, which is indicated by this spot here on the graph, we are going to be charged 32.5 cents at the start, and as soon as you hit $37,001, you're going to be charged $0.37 or 37 cents in the dollar. So we start off with the first step at the end of the 18,200 section, and then we move into the next section. And so we're just entering the value for the whole step there. You can see on another simple one, one's decreasing rate the more you use. So that's obviously encouraging you to use more over the longer run if you come across a stepwise graph like this. This one was the one I used for Bundaberg. The water rates, you can see here that the rates were, you were using 95 cents up to 183 kiloliters. And so if you used 0, you got charged 0. But you probably could even delete that bit there because we don't need that. That looks a whole lot better. You can see At 0 you got charged 95 cents per kilolitre, but if you use 0 you got charged nothing, up to 183. So we've got our first step, and then from 183 and any more you would just get charged $1.60 per kilolitre, and that's the second step here. If you have a look over at our piecewise linear graph here, what I have done is I've just said, well, at 0 you got charged 95 cents. So at 50 you got charged 95 cents. So I just put this in to help the scale. In fact, I don't even need to put that in until I get to 183. So that is not very nice. I would have to maybe put a 0 there. Is that going to be nice? And if I delete that? Anyway, you can see that we have a line segment at a certain gradient here. That's at 95 cents. And then we've got another gradient of 1.6. And that's this second bit here, which is the turning point. So here's the turning point. Just find a couple of dots along that line and draw that line segment in. When you're using Excel for a piecewise linear graph, or a continuous piecewise graph I should say, you're going to be using different rules, and so this is what I've done here. So you can see that I've got 3 different line segments. Now the first rule was just y equals 2 plus x. So I just did that for a variety of different values, and I did it for the whole 24 values, but I didn't need to do it all that way. But it makes it look good on Excel. So as I'm going along, you can see that y equals 2 plus x until I get to 0. And then at 0, you can see this is the turning point in the graph, that it's y equals 2 times x plus 2. And so that's going up for that one until we get to the value of 10, because that's where the turning point is. And then you can see that I've put in a different rule, that y equals 32 take x. Note the x value is just put up the top. For a discontinuous piecewise graph, I've put y values in 3 different rows. And that means it's just going to put in 3 different columns. Now, you can see that they're not really overlapping. And they're not overlapping on the graph here. So my first one is the x values below 0. So if I'm looking here, here's the x column, and these are the values below 0. So when y equals -4, x equals -4, and vice versa. So that's the first line on this graph, the x value below 0. Then the next series of values are is when y equals 5 plus x. So y equals 5 plus x, so y equals 5 plus 0 in this case, so that's 5 there, and we're working ourselves up. So this line is represented by the middle row of the y values. And then finally, we've got 6 takes x, so y equals 6 take x, and you can see that we've got the final discontinuous line there. Finally, students, can I get you to work on the mastery of this lesson, please?